so today we are going to do systems of nonlinear equations algebraically. So yesterday we did graphing, and we looked at all the different types of answers you could get graphing. So when we did that, we noticed that there can be one intersection with nonlinear functions. We can do two intersections or no intersections. Okay, so if you remember from yesterday, we talked a lot about that. So today we're looking at substitution, or doing it algebraically. Substitution is the best method when you're working with these types of equations because we want to make sure we can, it's the easiest way to solve them. Elimination is kind of tough because we can't get rid of a lot, although we can try it. Substitution tends to be the best. So if you look at the system here, we have, this is linear, it's in the form of y equals mx plus b, and this is my parabola here, okay? That's in the form of ax squared plus bx plus c, okay? So both of these are in function notation, and notice both of them have y alone. So I know y is equal to this, and I also know y is equal to this. So I can actually take the stuff y is here, and I can plug it in for the y here. So I have my equation x plus 1 equals x squared minus 2x minus 3. Okay? All right, so anytime you have an x squared, you know that you have to factor or use one of our three methods, completing the square or quadratic formula. You cannot just have, you can solve and take square roots, okay? When you have an a term and b term, you got to use factoring or completing the square or something like that, okay? So the first thing we always tell you is to get 0, to get one side equal to 0, so I'm going to subtract 1 on both sides. So I get x equals x squared minus 2x minus 4. And then I'm going to subtract x on both sides as well. I get 0 equals x squared minus 3x minus 4. And so now I always try to factor first. What are factors of negative 4? That'll get me negative 3. So I got x and x. So factors of negative 4 that give you negative 3 are negative 4 and a positive 1. And then if you remember from our unit, you got to get x alone on both sides. So your answers for x are 4 and negative 1. However, that's only our x coordinates of both of our points. So we have to now plug in our x values to find our y values. So y is equal to x plus 1. One of my x values is 4, so y is 4 plus 1. So one of the y values is 5. And then my other y value, negative 1 plus 1 is 0. And so you can always check this on a graph to make sure that these intersection points are correct. So this is an example where the intersections happen twice. There's two intersections. You might not be able to factor at all, or it might be no solution, so you might get something like that too. So just be aware of that. All right, so use substitution for this packet to solve these algebraically.